Please let me know if you cannot hear what I say or if there is any problem. Okay, right? So can you see my screen?
Yes, sir.
Okay, right. So let's start the lecture. So this is about Python programming, right? So I hope you have small experiences with Python when you are doing your advanced level. Some of the ICT students have this uh, experience. So so we are going during this lecture series. We will be discussing about the basics of Python, fundamentals of the Python to somewhat intermediate level of this programming. So we'll be doing some tests and we'll be doing some programming, and of course we'll be doing some assignments based on those the things that we learn. Okay, so hopefully this will be a good experience for you. And once this lecture series is concluded, I hope that you will be able to uh, start and continue some the programming, Python programming by yourselves to a certain extent. So of course I can teach you for certain level, but it's up to you to improve yourselves and get to know stuff, right? So the Python is actually, this is a little bit of history regarding Python. So Python was invented in 90s actually by a person called Guido van Rossum, right? So this Python is actually named after not the snake, right? So it's named after some TV program and movie series called, there's a uh, movie series called Monty Python. So search by yourself is a kind of a what do you call a comedy series, right? So it's named after this Monty Python uh, movie series actually, right? So not the snake. So he was kind of a nerd. That's why he developed a programming language anyway. So this is open source. So that means the source code of this Python program is open to anybody. So there are numerous kind of developers, and lot of functions have been included, and a lot of methods and all libraries are there for Python because of this open source uh, context, right? And this is also scalable. So scalable means you can write smaller programs, and of course you can write entire what do you call system application, or even can be used for artificial intelligence, machine learning, that type of things, because it's Python is very uh, scalable and very a lot of functions can be developed because of its nature, right? So I hope you know about Google, right? So Google has been using this Python from the beginning of this search engine. So basically, Python is one of the main programming languages that Google use for their search engine optimization, right? And currently also it's increasingly popular. So that is the small background about Python, and this is the person that who developed the Python, right? Guido van Rossum, who is uh, he's from Netherlands, and he developed this because he wants to provide freedom uh, to the developer and allow the developer to come up with new ideas, right? Okay, so now we have to think about why we learn Python and where is Python today. Okay, can you give like few minutes? The power is on. I will turn on this. Give me a few minutes, okay? Don't leave, please. Okay, sorry for the delay, right? So let's continue. So Python today is a active, one of the most active programming languages available, and it's used for scientific computing and data analysis. Extremely, I mean, wider range of applications are there, and one of the most important applications currently Python has been using is for machine learning and artificial intelligence. So for those things, the Python has been utilizing uh, at the moment. Okay, so there are several packages, what you call like libraries, available for Python. So as an example, NumPy is for mathematical applications, right? So Pandas also for mathematical and data science applications. So Matplot is for actually plotting mathematical graphs and things like that. SciPy means is scientific Python, that is for scientific based applications. So as a scientist, you may need to analyze your data. You may need to analyze images. So those things can be utilized by using this SciPy uh, Python packages. Likewise, it's a lot of community developed and community supported packages are there for Python because of its this versatility and because of its open source nature, right? And also Python has good uh, online documentation. So whenever you have a problem regarding the development that you are doing, you can easily go to the online documentation and you can come up with solutions with that. So that is also a advantage when Python is used as preferred programming language, right? So there are two main methods of using Python. So first one is what you call IPython. So this one we will be using in the first part of the lecture series. So this this version is interactive, right? So it can be used as a learning tool for Python. So because of its interactive, you can write your code directly and you can get the answer right away, right? You don't have to run a script, or you don't have to run run separate scripts to get to the answers. So this is ideal for learning the Python language, and that is why this IPython mode is very popular. And also there's the usual Python scripts. So if you want to write several lines of codes, or if you want to write say some application software using Python, of course, then you have to use Python scripts, right? So later part of the lecture series, we will be using Python scripts, but in the beginning, we will be using this IPython, or what you call interactive Python, to learn the basics and understand the main components of Python programming. Okay, so that is somewhat the background of these Python 2 modes, or how to use the Python environment, right? So to use Python as interactive tool, we can use this Jupyter notebooks, what you call it. I'll show you how to install this one. Okay, so all of you have laptops with you, right? Can somebody answer? All of you have laptops with you, right? You have access to computers, right? Can somebody say yes or no? Hello? Do you guys have laptops with you? I mean, not now. So usually, do you have your laptops with you? So sorry, yes or no?
Some have, but not now.
Okay, so you guys have. I assume that you have laptops, right? As a ICT student, you must have laptops. So on your laptops, you need to install this Python environment, right? I'll show you how to do it, and I will show the links as well. So this Jupyter notebook we'll be using to do the practice sessions, or what you call when we are learning, we will be using this Jupyter notebook. So it is interactive one, and it is easy to use environment. I'll show you how to install it, and it is web based, right? So you don't have to write scripts, but instead of that, you can directly open this Jupyter notebook on your preferred browser, or what you call Chrome, or Firefox, or Microsoft Edge, something, and then you can type the code at this notebook, and you can get the results right away. So this is already come with useful packages, several useful packages that I discussed earlier, like NumPy and Matplotlib. So those libraries are already installed in this Jupyter notebook. So we can directly use this to do the lecture, and to do the what you call practice sessions while we are doing while we are learning about different types of Python data types, or Python functions, or Python methods. Okay, so that would be good for you to get an interactive idea about what this Python language is, right? So this is the link that you need to go and install this Jupyter Notebook or Python environment, right? So Python environment is not installed in your laptops or computers by default, right? So you have to go to this. Of course, you can install Python as a separate environment or working environment, but my recommendation is it will ask, it will allow you to download. It will, can you see my screen? I hope that you can see my screen. So it will uh, allow you to download Anaconda environment, which is basically environment for Python programming, right? So this is free to use, but of course there are some there's a paid version, but you can download this and install, uh, and you can use Python Jupyter Notebook. Right away from this environment. Okay, let me show you the environment. Hello, can you hear me now? There was an internet problem because today the power in Ratmalana is going. I mean, disconnecting frequently. Okay, let me share my screen. Okay, so can you see my screen?
Yes, sir.
Okay. Right. So this is the this is the Python environment I want you to install. So if you have your computers with you, please go and check this link. Okay. So it's if you search this anaconda.com in Google, you will get directly access to this access to the sorry. Okay. So if you type Anaconda distribution, it will allow you to download this environment. So please next time, please download and install this Anaconda Python environment. So we'll be together. We'll be using this to test different aspects and to try out Python programs, right? So please download and install this. It's very simple. I think all of you can do it by yourself. But if you don't, if you are not able to install it properly, please let me know. I will show you how to install it again, right? So you just have to download this one and follow the instructions to install the Anaconda Python environment. Okay. So once you install it, so you will see a screen like this. So there are various type of integrated development environments that you can use for Python programming, right? So there's something called uh, Jupyter Notebook, and of course Visual Studio Code, the Spider, and PyCharm. Those things, they are actually programming. Integrated development environments for Python programs, right? So we will be using this Jupyter Notebook uh, to learn Python, and because it's as I informed you and told you earlier, it's an interactive way of learning and coding Python. So it is easy to understand about these basics of Python and basics Python coding styles, right? So this is very important because of that. So please, even you don't have your laptops with you now, later on, please go to this Anaconda distribution and install this Python environment, right? So it will be easier for you and easier for me to teach you, and it is easier for you to learn this Python programming. Okay, so that is basic background of Python, right? So let me show you my Anaconda environment. So when you install your Anaconda Python environment, you will have it installed as a separate program. And once you properly initialize it, it will start the environment without a problem. So you can have all your packages installed without any problem. So likewise, your program is installed like that, right? So I'll be using this one to show you some demonstrations, but next week I'll show you how to initialize your own Jupyter Notebook and how to work with Jupyter Notebook and get answers and interactive codings using Python. Okay, so that is the background of Python environment and Python programming. So next, then we have to learn about different Python data types and different Python functions. And there is something called Python methods and Python object-oriented programming. Everything is there. So let's take one by one, and we'll discuss about while doing some practices about Python programming, right? So Python data types will there are some key data types that you will be using with Python, right? So these data types are basic building blocks when you constructing or developing codes, right? So this is the smallest important coding that you will be you'll be needing to construct a larger program, right? So let's quickly discuss about the basic data types of Python, and then we'll do some exercises or do some demonstration using Jupyter Notebook about this Python data types, right? So these are the data types and data structures of Python, right? So have you heard about integers? Somebody? Have you heard about integers? Numbers. So integers that we consider as whole numbers, right? So whole numbers means numbers like this. So 3, 300, 200, numbers like that are considered as whole numbers, right? So not only the positive numbers, but also the negative numbers like -3 or -100, right? -20. Those numbers also considered as right integers, right? So the integer data type is one of the main data types that we will be dealing when it comes to Python programming, right? So integers are there like whole numbers. The second data type is what you call floats, right? Floating point numbers, we say. So we and well, say 100.0, right? So we have defined a decimal point number here. So Python automatically recognize this one as a floating point number instead of a whole number because it has one decimal point, right? So numbers with decimal points, we consider them as floating point numbers, right? So this is the next data type that we will be dealing when it comes to Python. So the next one is, so this is actually the name, right? This is the Python interpretation, right? So when you are, we'll of course discuss this later, but when you are assigning variables, right? So you have to sometimes indicate uh, this data type that you will be using sometimes, but most of the time you don't need to indicate because Python is a dynamic type programming language. So all the time you don't have to mention the data type of a variable all the time. So it's an advantage. We are going to discuss it, but this is the way the Python understand what type of data that you will be using. Okay, so we discussed about integers, and then we discussed about floating point numbers, and then we have strings, right? The letters, right? So these letters also a kind of a data type, but you will be using uh, inverted commas or double inverted commas to show that it is a string type, right? So that is the next type of data type that you'll be using in Python. Of course, there's data structures. So these are data types, right? So next we have to talk about data structures, right? So list is a data structure that we'll be using in Python. It is a ordered sequence of objects, right? It's actually numbered, we're indexed. We're of course going to discuss about that. So it is indexed. So you can call it index number and access those data, right? So that is a data structure that called lists we'll be using in Python, right? And there's another data structure which is called dictionary, right? So these dictionaries have a key and a value, right? So this is we will be discussing this. I mean later, lengthily, but for your information, I'll be hello. I think it got disconnected. Can you hear me and see my screen?
You can hear you. One second screen.
Sorry, what?
We can hear you, sir, but can't see the screen. Share screen.
I can't see the screen. Okay. So I am not the host anymore. Can somebody make me host? You cannot share the screen. Mm, ප්‍රසාද් මේ මාව හෝස් කරන්න පුළුවන්ද? Okay. Can you now see my screen? Can you guys see my screen now? Hello. Can you see my screen? So
I can see your screen, sir.
okay. Okay, thanks. So please respond, okay? Otherwise, I'm kind of unaware what's happening. So thank you for that. So yeah, so we discussed until here, right? The tuples. So lists and tuples are somewhat similar, right? But there's a major difference when it comes to tuples and lists. So the main difference is that so the lists you can change the elements inside of that said list, right? So we'll be discussing this in detail, but for information, so when it comes to tuples, you cannot actually change what is inside in that specific tuple. So you define a list inside. So you can define a list with square brackets. You can define a tuple with parentheses, right? So the main difference is this immutability. We'll discuss that one later, but this is the main difference. The immutability, tuples can be accessed but cannot change, but lists can be accessed, and the elements inside that list can change according to the requirement of the user. So that is the two major difference between the list and tuples. So those two are data structures actually, right? So that is the main difference. Then there's something called sets. So this sets also a kind of a data structure which contains only unique elements inside that specific set. So as an example, so in this here there's A and B are there inside this inside the set. But if you want to insert another A like this, A like this, so this will not be accepted, right? This will not be accepted because this is a duplicate, right? Because this is a duplicate, the set data type will not accept this second A. So right, likewise, the sets, what you call is collection of unique objects, right? So that is a data structure as well. And finally, we have booleans, right? So booleans are logical values, right? So I think you are familiar with this, the booleans, right? You may have come across this previously as well. So true and false, that is boolean values, and that is also actually a data type. It's not a data structure, it's a data type that you will be using in Python. So these are the main data structures and data types you will be using in Python. So these are the building blocks of the larger code that you will be constructing, right? So any questions so far? Any questions, any things that you need to get clarified before we move forward? Okay, so I hope that understood these basics. Okay, so let me move on to the next step. So we'll discuss these data types one by one, and it is very important to understand precisely what each data types do and precisely what kind of situations that you will be needing these data types to construct your Python program, right? So one of the main data types that you will be come across with when it comes to programming, not only Python, but for programming, it's numbers, right? So there are two main number types that as we discussed previously. So first number type is the integers, whole numbers that you'll be using. So it can be a negative or a positive number, but whole numbers like 1, -1, or 2, or 100, right? Things like that. Those are what you call integers, whole numbers. So it can be a negative value like this or a positive value. It doesn't matter, right? And then you have floating point numbers, right? Floating point numbers means this numbers that which have decimal points, right? It can be a negative number like this, right? Or a positive number like this. So it can have several decimal points or one decimal point, right? Depending on your requirement. So those are the two main number types that you will come across when it comes to programming, right? So of course we have to use these basic number types for mathematical calculations when it comes to programming, right? So of course you can use these numbers directly for mathematical calculations, and also you can use these numbers and assign them to variables, right? And these variables can then be used to manipulate the you can manipulate mathematically because these numbers now are assigned to variables, right? So things like that. So let's check some examples using Jupyter Notebook. Okay, so let me open my Jupyter Notebook. So what you have to, once you install this, what you have to do is just to launch this one, right? So if you launch in this one, it will open default directory. And in my case, I have created several notebooks. So yeah, then what you have to do is you can open this notebook and you can interact. So this is actually Python notebook environment. So please install this Anaconda Python environment by next week. So we'll be discussing and I'll demonstrate how to create a Python notebook in Jupyter and how to interact with that one. Okay, so please make sure that you have this program installed by next week. Okay, so let's basically discuss about here the type of numbers that you'll be using in Python. So now basically we discussed about integers and floating point numbers, floats, and then how to do basic arithmetics, right? So addition, subtraction, and division, those basic mathematics, right? And there's something called arithmetically, there's something called classical division and flow division, right? So that also we'll discuss. So that also we'll discuss. And then finally, we'll discuss how to assign objects in Python. That means how to assign variables, right? So as a ICT student, maybe you have come across these things previously, but for to be the safe side, we'll be discussing this from the beginning for specifically for Python, right? So basically Python has, as I told you, integer numbers and uh, floating point numbers, right? So those are the two main number types that we will be using. And there's also scientific number, which is considered as a floating point number. So these are the examples. So integers, of course, whole numbers can be 1, 2, or negative 5,000, whatever the whole number that you define. It belongs to this integer type, right? Whole numbers. So then you have these floating point numbers, which is like point numbers, say 1.2, maybe negative 0.5. That is also a floating point number. And this scientific writing, right? So this is actually, what is actually this? 2e2 means actually the power of 10, right? So this is actually let me show you. So 2e2, this is equal 2 times 10 to the power 2, right? And 3e2 is actually equal 3 to 10 to the power 10 to the power 3. So this is actually, sorry, power 2, right? Right, power 2. So this is actually the power 10 to the power of this value. This is what you call scientific numbering, right? And in Python, this is also considered as float, right? Floating point number. So that is what shown in here, right? So you can use either simple or capital E to indicate these scientific numbers, right? So let's do some basic arithmetics. So this is the environment that you will be using and you will be working with. So each cell you can indicate a Python code, right? So each cell you can indicate Python code, and then you can run this specific cell, only this specific cell, and you can see the results. So that is the advantage of using this Jupyter notebooks, because you can write the code and you can get the results right away, right? So that's why we'll be using these Jupyter notebooks for the first parts of this lecture series, right? To understand and to get familiar with typical Python codes, right? So let's simply do some basic arithmetics using Python. So this is the addition. I mean, you will be, of course, familiar with this. So this is basic things. So you can directly input a code like this, and if you run that specific cell, you will get the output. So 2 plus 1 is actually 3. So that is what we have. I mean, this Python code puts as an output, right? So this is subtraction. Like a calculator, you can do this, right? So when you run this one, of course, you can do these basic calculations likewise, right? And multiplication. So this here you have used the positive sign and negative sign, and multiplication you will be using the star sign, right? So there's no multiplication sign like cross on the keyboard. So instead of that, you will be using star sign. So when you run this one, and you will get the multiplication of 2 times 2, right? So it can be anything. 2 times 3 also can get the output. So this is the input and this is the output that you will be getting. And also the normal division, the classical division. So 7 divided by 4, you will get 1.75, right? So this is the classical division that you will do, right? But say that you will divide 6 by 4, so you will get 1.5. So that is the output is a floating point number, right? And if you divided 8 by 4, that is 2, a whole number, right? But this is the output division. The output of division will also always be a floating point number because it's division, right? So even though this is 2, this is indicated at 2.0, right? That means it's a floating point number, not a integer, right? This is an integer. 6 is an integer, of course, because it doesn't have any decimal points, right? Okay, so this is the classical division that you will be using in Python. But there is another division, what do you call flow division, right? So instead of 1 forward slash, right, or one division operators, you will be use 2 division operators, right? So what actually this does is it will output the results as a integer, right? So if I run this one, so see, actually it will round up the output and give you the integer. So actually 9 divided by 4 is 2.25, right? But if you I'm extremely sorry, there has been another power failure here, so the internet got disconnected. Um, but I hope that you can hear me, right?
Yes, sir.
Okay. Sorry. There has been a continuous power failures in Ratmalana because of some transformer problem. So that's why this internet get disconnected continuously. So sorry for that. And okay, so we'll be discussing about this division and floor division, right? So in a division, so you will be getting the 14 point number as the output, right? But when it comes to floor division, you can clearly see the difference, right? You do not have these decimal points, but you have this whole integer number as the output. So that is the actually difference between the classical division as shown in here and the floor division. So say let's try another example. If you put 10 here, so output will be what? 2.5, right? So in the floor division, then now the output is again 2, right? It will just take this whole number as the integer output and it will output it like this, right? So if you put 11, it's the same, right? So 2.75 for the floor division, still you will get 2, right? This whole number will be used as the output for the floor division, right? So that is uh, kind of a option that you have in Python. There are several applications we'll be discussing those things in the future. So that's why they have given you an option like that, right? So this is the uh, division and difference between division and floor division in Python, right? So now with the floor division, we can get the whole number, right? So without rounding, we can get the whole number in the floor when it comes to floor division. Say if you need to check the remainder after division, there's a option for that as well. So for that option, you can use a function called modulo function, right? So in the modulo function, what it does is we'll be using this percentage sign as the operator. So in the modulo sign, what you can do is, so it will give you the remainder after the division is done, right? So if you divided 7 by 2, right? The remainder is actually 1, right? So let me show you a example. So if you classically divide 7 by 2, you will get 3.5, right? That means you will get 6 and remainder is 1, right? So this is what happening here. So you will get that remainder in here, right? Let me show you like in simple terms. Okay, so if you divided 7 by 2, right? So you will get 3 and this is 6 and remainder is 1, right? So this remainder can be obtained using this modulo function, right? So using this modulo function, you can get the remainder, right? So this is the function that you can get that. So why you need this? So we'll discuss about those applications in the future as well. So actually, with this modulo, you can check whether a number is an odd number or an even number, right? So which is very useful when it comes to construct different algorithms, right? So as an example, if this number is 6, if you run the modulo function, the remainder is actually 0. So that is true, right? So even in classical division, it says 3.0. So nothing is remaining. You can divide 6 by 2 without any remainings, right? So 6 is what you call it as an even number, right? So if it is an even number, the remainder is 0. But if you have odd number like 7, the remainder is 1. Just this is common for any odd or an even number. So the advantage of modulo is you can check whether a number or a result is even or odd according to your requirement, right? So in such a way, you can build your function or build your algorithm accordingly, right? So of course we'll be using these things in soon. So just keep in your mind that there are some applications, arithmetic applications that you can use in Python, like flow division and modulo. So they have two different advantages. Okay, so now we have discussed about basic maths, basic arithmetics like addition, subtraction, multiplication, and how to get flow division, and finally how to get modulo, right? So then we can discuss about the powers, right? How to get a power and what is the syntax, right? What is the syntax that you will be using to get power using Python, right? So this is the syntax that you will be using. You instead of 1 star, which is used for multiplication, you can use double stars, right? Stars. This double stars means we are actually checking its power, not multiplication, but just power. So 2 to the power 3. So this is actually similar to, let me show you. This is actually star 3. This is actually similar to 2 to the power 3, which is equal to what? 8, right? So that means 2 times 2 times 2, right? So this is 8. So this is actually 2 to the power 3, right? This double star means so this double star means it is calling the power of 3. So let's check the results. As we discussed, it is 3, right? So also we can obtain the roots of any number in the similar manner. So actually, what you call root is something like this, right? So let me show you. So root is something like this. So 4 root is equal to this one, right? 4 to the power 0.5, right? So this is actually, we can write in Python like this, star 0.5. So this double multiplication means we are checking the power of that specific number, right? So here 4 star times star means this is 4 to the power 0.5. That is, we are checking the root of 4, right? So root of 4 is actually what? 2, right? So similarly, root of 9 is, right, 3, right? So it can be any number that you want to check, can be 11 or 110, right? Root, you can get the root number without any problem, right? So if this 144, it's 12, right? So like that, you can get the root of any number, but the syntax is like this, double stars, right? So any problems so far? You can type any questions if you have, or you can unmute and you can ask the question. So these are the basic mathematics and basic syntax of Python coding. If you are doing any mathematics operations involving the numbers, right? So we discussed about addition, subtraction, which is not that difficult to understand. And there's a classical division. It's normal the way that we divide. And there's a floor division, which is the whole number that we will be considering for further calculations. And then there's modulo, the remainder. We'll check in the remainder. And finally, we discussed about the powers. So you can get the powers or roots in the same manner by using double star syntax, right? So any questions so far? Any unclear positions, unclear parts? Okay, so I guess that you don't have any questions. So let us continue, right? Okay, so then there's something called the order of operation in Python, right? So in order of operation, you have to consider what sign or what operations are done first. So can somebody, I mean, anybody, write the answer in the chat for this specific output? Is it 12 times 13 or 100 105, or what is the answer? Can you just guess the answer and write it in the chat box? Somebody, what is the answer that you think? Maybe you think this is actually 12 times 13, right? But doesn't happen like that. The multiplication sign is the highest hierarchy when it comes to operations. So the order of operation happens. Yeah, so order of operation happens actually multiplication first, and then the addition. So one person has given their correct answer. Yeah, this is the output is actually 105, right? Not 12 times 30, right? So this is dominant. The multiplication is dominant when it comes to order of operation. So you need to think about that as well. So I think you have a little bit of exposure regarding this when it comes to other programming languages. Similar thing apply here, right? So the multiplication is the dominant operation, and then the addition and subtraction, right? So you have to keep that in your mind as well. So if you need to multiply 12 times 30, then it's better to use parentheses, right? It's always better to use parentheses for your calculations to make it clearer for you and for to get the correct answer as well, right? So this is need to be considered, right? Okay, so with this the arithmetic and numerical number types of Python is over. So we'll be discussing next is variable assignment. So before we are going to variable assignments, are you okay with the content that we discussed so far? Are you, if you have any questions, please ask. No questions? Okay, so then let's move on to some quizzes. Please give your answers in the chat, right? And send me a text message, I mean, chat message. So what is the answer for this one? Quickly. Please use chat message to give you answer. So it says which one of these is a floating point number? A, B, C, D, O, E. You can, okay. Sorry. So you can use this one, A, B, C, D, E. What is the answer? Which one? Which one of the following is a floating point number? Please answer. Otherwise, I'm not sure whether you are sleeping or listening to the lecture.
Answer is A, sir.
So yeah, this is one. A is the answer, right? Okay, thank you. So what about this one? So which one of these will output the result of 36? Is it A, B, C, D, or E?
C, sir.
So C. Are you sure?
Yeah.
So A. So this is A, this is B, this is C, this is D, this is C. 6 to the power of the C. This is actually this first one is, it will become an error. Second one is what? The answer. This is actually also 6 to the power.
Answer is D.
Right. So this is D actually. This is the correct answer, right? So this is actually 6 to the power 6, right? 6 to the power 6. And the answer here and answer here is the same, right? So the correct answer is actually the D one. D, right? Okay. So next, what is the answers for this one?
C.
So the answer is actually C, because we are using the classical division, right? In the classical division, we'll get the floating point answer. But when it comes to, say, flow division, right? So the answer will be 0, right? And if you get the modulo, sorry, if you take the modulo, then this answer will be, right, 1. So just 2 different answers will be there, right? Okay, so any questions so far? Any questions? So okay, so because you do not have any questions, and I also think that this part is fairly simple for you. So we'll move on to the next part, which is variable assignment, right? So currently we directly manipulate the numbers, right? Without assigning into anything else, we directly uh, interact with the numbers, right? But most of the times, this is not very practical, right? Because we don't know what this number means. And if we want to use this number again and again, it can be problematic, right? So because of that, instead of using just only the numbers, we can use variables, right? Meaningful variables. So that meaningful variables are extremely useful to obtain the results, store results, and retrieve uh, the output after some kind of a mathematical operation, right? Or the processing, after processing data. So because of that, we need to use variables to store numbers or store data structures, right? So for as an example, so this is a meaningful variable assignment, right? So here it says I have 2 dogs. So you can create a variable. So my underscore dogs, which is equal to 2. So instead of writing just 2, now uh, somebody else who's reading through the program can understand. So this means that this person has 2 dogs, right? So we have assigned a variable to the number, So we can use this variable again and again, right? And there are some very important rules when it comes to variable. You need to keep this one in mind, right? So these rules are not only applicable for Python, but most of the programming languages, the rules are the same. So you may already know these things, but let's discuss and get things solid before moving on, right? So one of the main rules of using variables is that you can start a variable with a number, right? So it will give you an error. It will output an error if you start a variable with a number. So it has to be a letter or an underscore, right? So you have to keep that one in mind as well. So names cannot be start with a number. It should always be underscore or a letter, right? So second rule, there cannot be any spaces in the name, right? So in the previous example also, so if I write this variable like this, sorry, so if I write this, so if I write this variable like this, equals to, so there's a space here, right? Can see. So because of this space, this variable will not be accepted, right? So you cannot have any spaces in the variable name, right? Instead you can use actually the underscore. So we have done the same thing here. So we have used underscore here. So using underscore is fine. So you cannot use any space. So space in Python, we'll discuss this one also. Space in Python has separate functionality, right? Therefore, you cannot use spaces with the names, variable names, right? And the third important rule is you cannot use any of these mentioned symbols, right? Any of these symbols anywhere in your variable, right? So these what do you call special characters have a different name, different meaning in Python, right? They have been used in different capacity. Of course, it's, you know, this plus, minus, and star. Those things are used in arithmetic operations, and there's a forward slash is also used in different operations. These adds, hash, those things also have used in different operations, right? So because of that, you cannot use these special characters in a variable name, right? Definitely you will get an error, right? So next one is that this is not actually not a rule. It's a uh, uh, kind of a convention or widely accepted among the community to use uh, lowercase variables in when you're naming or when you're assigning variable to a number or some kind of a data structure, right? So this PEP means the Python PEP is a Python actually what do you call agreement between among the users to use that lowercase letters for variables. Because actually uppercase letters, we'll learn that later as well. Uppercase letters are preferred to be used as Python functions. So then this coding can be understood by different programmer, right? Say that you like large codes. Those codes do not done by one person, a single person. The team is there, right? So when it comes to building up these larger codes, small part of these code done by different persons. So there has to be a kind of a convention, no common understanding between these programmers. So that's why they have defined to use lowercase letters for variables and uppercase letters for functions, right? We'll discuss about the functions later, but that is the general convention. Of course, you can use capital letters for variables and lowercase letters for function, but for a better understanding of your code to other person, that is the reason that it is mentioned to use this lowercase case letters for variable assignment, right? So hope you understand that part. And finally, it is recommend and not recommend, but it's always good practice to avoid special names which are already defined in Python, right? So like list, right? Strings, str or int, right? Those words have been already defined inside in Python. Of course, you can accept it, but when your code is larger and when you need this list function somewhere else, so then the Python code will get confused whether you are calling the list function which is in build or you are calling this variable. So that is the reason why it's asking to avoid these inbuilt Python function words as what do you call variables, right? So that is basically the rules, the important rules when it's come to naming variables, right? So another important, another what do you call advantage of Python, right? So if you are familiar with C++, so you have to define, you have to tell that program that you are using these variables in your program. Like if you want to use an integer in C, you have to tell int number, something like that, right? So you have to define. But in Python, you don't have to define your number, variable type, right? So you can, while you are constructing your code, you can allocate or you can define your variables. So which is called dynamic typing. So you can reassign variables to different data types without any problem, right? Because in C also, if you define it as int and say that you assign it a 14-point number like this, right? So this will give an error, syntax error, because initially we are saying it's an integer and later on we assign a floating point number. So this is not accepted in C programming languages like C and C++, right? But when it comes to Python, this is acceptable. So because you do not define its type, right? It's dynamically allocated. You can assign it as number 1 first, and later on you can reassign it as 2.7, and Python will not complain. It will accept, right? So that is why it is, the code Python is very flexible when it comes to assigning these data types, right? And it is called dynamic typing. Programs which do not allow you to change its type, data type, they are called statically typed, right? That means programs like C or C++, something like that, right? Java, things like that. So that dynamic typing advantage is also there. right? So did you understand what I said? Did you understand the difference between this dynamic typing and statically typing? Statically typing. If you have any questions, please raise your questions in the chat box, and you can of course ask, right? So that is one of the advantage in Python. So it is dynamically typing, that you can on the way sign your variables while you are constructing your codes, right? Okay. So this is an example of statically typing and dynamically typing. So see, this is first example is Python example, right? So you have variable name, right? So initially, what is the type of this variable? What is the data type of this? Can somebody say? Can somebody type the answer? What is the data type of this one? This specific first. Yeah. So this is integer, right? This is integer data type, right? And now, what is this data type? This is integer. The first one is integer data type. It's okay. So what is this data type? Is the second part. No, this is actually not a string. This is actually a data structure which you call list, right? Let me show you again. So let me show you again about this data type. So please get a clear idea about this one, okay? So strings, you just directly assign letters, right? So as an example, text, we can assign it as hello, right? This is a string, right? This is a string. But now what we had was something like this, right? Which is a list, right? We'll be discussing this further, but for you understanding. So Frankie, and there was some other name, something like. So this is what you call a list, because it is inside a square brackets. See, so this is a data structure list, right? So right, let me go back. Okay, let me go back. Right, so this is actually integer type, right? This is actually integer type. This one actually a list type, right? So in Python, this is actually okay, right? This is actually okay. It allows you to change your data type in the middle of your code, right? So this is what you call dynamic typing, right? This is what you call dynamic typing. So this is actually advantageous sometimes, right? You don't have to go back to the top, or go back to the header file, so you don't have to change, right? You can simply change whatever the value that you require, right? So statically typing, this is actually what you call static typing. Sorry. So this is what you call actually static typing. See, so this is like program languages like C or C++. So they use this static typing, which means, so here you define your variable first. So now this is an integer. So you define your variable first. And if you try to reallocate this variable for a different data type, right? So this is actually a string, right? So if you try to reallocate this same variable to a different data type, then you will end up with an error, right? So of course this can be the same data type. Like if you reallocate this like 2, this is okay. But if you change the type of the variable, then it will definitely end up with an error. So that is the difference between dynamic typing and static typing. And we are involving with dynamic typing, which is advantageous when it comes to Python. Sorry, Python programming, right? So any question about this? Do you have any questions regarding this one? Any questions? Any unclear part? So are you okay with this one? Okay, let me move to the next slide. So of course there are some pros and cons in dynamic typing, right? So the pros are it's very easy to work. So you don't have to think about all the variables that you will be using throughout the program, right? You can have like only kind of an idea what kind of variables that you'll be using. Then you can construct your uh, program accordingly. So while you are writing the program, you can come up with the variables and you can reassign these variables without any problem. Because of that, the development time is faster, right? Because you don't have to plan a lot, like when it comes to variable. But there's also cons as well, definitely, right? So the con or the disadvantage is that like you will you without knowing you can assign the same variable name to a different variable, not I mean variable type. So as an example, when say you define a num variable, right? So initially you assign it as a integer, right? Say 100. So this is okay, right? While your program is developing, accidentally accidentally you reassign this num to a 14-point number, right? So now initially it was an integer and now it's a float. But you may do not know about this change. If it is a large code with a lot of lines, this mistake can slip through without any uh, information, right? Without noticing. So that can happen and that can cause bugs, right? So there is a disadvantage of this dynamic typing. So the advantage is you don't have to plan. It is easy to work with. and you can assign your variables when you are developing your code. But disadvantage is that mistakes can happen. You can assign the same variable name to different data types, right? So that is the disadvantage. So advantage and both disadvantages and advantages are there for dynamic typing, right? So there's a method or a function called, we'll do some examples, called type. So if you are not sure about the variable type, you can always use this type function to check what is the variable type, whether it is a float, whether it is an integer, whether it's say a list type, or it's a string type, whatever the type, and you can check with this type function, right? I'll show some examples as well. So we'll discuss about some examples. So do you have any questions so far? Please type any questions if you have in the chat. Okay, so shall we move on to this Jupyter notebook? Okay, so let's discuss about this variable assignment. So we, in the previous examples, I used Python as just a calculator, right? To to perform arithmetic operations, simple arithmetic operations like multiplication, division, and modulus, floor division, things like that, right? So then we can assign these numbers to variables, right? So this is what I have done here. So now we have created an object all day, right? So this is actually a variable, right? So then we can assign this number to whatever the number that we would like to assign it, right? So in this case, we have assigned number 5, right? So we use this equal sign. So that means a equal 5, right? To assign. So this one also you have to keep in your mind. So single equation equal sign is used for assign, right? So now this will be assigned. The a is assigned as 5, right? So now let me run the code. So here this assignment happens, and here we are checking the value of 5. Value of a. So output should be 5, right? So if I allocate value 6, the output will be 6. If I allocate value 100, then output will be 100, right? So let's move back to the original value. Yeah, so a is equal to 5, that we have assigned this value, right? So if I call a in this Python script at this moment, it will consider it as 5, right? So instead of calling 5 directly, we can call this, or we can ask Python to use these variables to do any mathematical or any operation. Okay, so in this case, so if I add a to a, this output will be 10, because now Python treat it as, so the Python is treating a as the number 5, right? So let's you are okay with that one, right? So I hope, because you may have done these things previously as well, right? So now it's a is considered as 5. So no problem with that one. So will Python allow us to reassign this variable? What do you think? Yes or no? You can type your answers. Will Python, right? Will Python allow us to override it? What do you think? According to the discussion that we had previously, what do you think? Whether it will allow us to reassign or not? Because Python is dynamically typing, of course, it will allow us to reassign. So now, if I check, sorry, if I reassign the value number 10, and if I check, see, it will reassign. So this is actually a plus a. That means it is, the value is not reassigned. A is still 5 until this point, right? Here we reassign the value, right? So when we reassign the value and if we check, we will get number 10. So Python will allow us to override it, right? So that is what we call dynamical typing, but still this is in the same domain. So this is still an integer. So still you cannot say that dynamically typing is happening here, but it will allow us to, I mean, Python will allow us to reassign the variable, right? And say, what is the output here, right? 10. So now we will assign a with 2s. So what do you think the answer will be? Please type. Please give your answers. Will it be 10 or will it be 20? Will it be 5? So what is the answer for this one? Please give your feedback. Yeah, so the answer is actually 20, right? Because we have a as 10 here, right? So 10 plus 10 will be assigned to a again, right? So this will be then 20. So same variable name, but we will be reassigning the values. So let me run it again. So this one, and the final output will be 20, like we expected, right? So this shows you the dynamical typing, and that Python allows you to reassign variable according to your requirements, right? So any questions until that, up to that point? Please type if you have any questions. Okay, so I hope that this part is clear. So let's move on to the next part. So which is the rules of Python variable assignment, right? So this part we already discussed that there are few rules that you need to follow when it comes to Python variable naming, right? So the first one is that this is a strict rule that you need to follow. Your name cannot be, or the variable cannot be start with a number, and there can be no spaces. So this cannot start with a number, right? That is a first rule. and there can be no spaces in a variable name. Of course, you can use underscore instead of that, and you cannot use any special symbols mentioned here for variable naming, right? And the fourth one is not a rule, but it's a kind of a convention that means kind of an agreement among the Python coders to have variable names with lowercase letters. So there is some kind of a what do you call agreement between uh, agreement among the Python coding community, right? The other one is that, so to avoid these characters, because this will confuse you as to 1 or 0, right? So this is also not a rule. It's just the kind of an agreement between among the community. So you don't misunderstand the variable name with the letters, right? But you don't have to do this all the time. It's just an kind of a suggestion that you have among the community. And this is the sixth one is kind of a not a rule, but it's better to avoid Python integrated keywords, right? Like list, string, int, float. So those need to be avoided as much as possible when it comes to naming Python variables, right? Otherwise, as I told you before, so while you have constructing your codes, at some point it will give you an error, because the Python will now get confused whether you are referring to its keyword or you are referring to a variable name. So that's problem will be there always. So try to avoid all the Python keywords when it comes to variable name, right? So that part is there. Okay, let's check with some examples. So another important fact is that when it comes to naming or creating Python variables, always try to create a variable with meaningful names, right? So this is a small example that it is calculating the taxes, right? So of course you can use a variable like this, right? So if you type A, type A, and if you type B, and if you type C here, right? So nobody knows what A means or what C means or what B means, right? But nobody knows. Only the person who wrote the program uh, understand that A is this thing, B is this thing, and C is this thing, right? But the person who wrote the program may also forget what is this each variable represents after some time. That happens. So that is something very usual, right? So it is better to have meaningful variable names. Always try to have meaningful variable names with your codes, right? So this is actually meaningful variable names, right? So my income is a meaningful one. So anybody can understand what is the value of this one, or what is the value that you need to put. So tax rate is meaningful variable, right? So final my taxes is also, you know that it is the final output, and it can be calculated using the above two variables. So likewise, the variables name need to be checked properly and need to be named properly to give you clear idea what is happening, right? So here also simple calculation is there. So your tax can be calculated by multiplying your income and tax rate, right? These two variables have been previously identified, and the values of these variables have been also assigned, right? So note that, see, the name of this variable is, all the characters are simple characters and there are no spaces. They have used underscores, right? So this actually agrees with the rules that we discussed earlier, right? So if you run this one, and it will show you the real value, right? So if you change this value and then run again, see, so it will update the values, and everything has its own meaning, and everything is clear to the user and maybe to the next developer who would be doing the code, right? So this is about this variable naming and variable assignments. So any questions, any clarifications that you need? Did you understand what we discussed so far about variables? If you have any questions, you can ask me. You can just type your questions, or you can directly ask. Okay, so let us do some okay. So let us do some other uh, data types, right? So far we have discussed about numbers, right? And then about variables assignment, and then we need to discuss about the other data types, right? So the string is the other data type that we will be using frequently when it comes to Python programming. So strings are actually sequence of characters, right? They're sequence of characters. That means it has specific place and specific index number, right? So you can define a string variable or string data type using single or double quotes. So here, 8 single quotes, right? Hello, and this is double quotes, right? So these both of them are accepted, right? Say if you have a single quote inside your text, right? In that case, you need to use outer double quotes. So if you use this outer double quotes, then Python knows this is a string, right? So it knows that this is a string, and it will consider this whole part as a string, right? So that is an advantage of using this mix of double and single quotes uh, when it comes to string declaration, right? So hope you understood about the way that you declare a string in Python. So either you use a single quote like this or double quote like this. But if you have any single quotes inside your string, then you can use double quotes, and you can integrate the single quotes as a part of the string, right? Like shown in here. So let me explain some basic rules of strings, right? So strings are, as I told you, ordered sequence of characters, right? It's a set of characters that is in a ordered sequence. So that means it is possible for programmer, for user to do this thing called indexing and something that's called slicing, right? So this will allow you to or the programmer to grab a certain element from this string and a set only a character or set of characters. It depends on the application or the requirement. So the slicing and indexing allow this uh, programmer to grab or retrieve data from these strings, right? So indexing notation, we'll be discussing this with some examples. So indexing notation, we'll be using square brackets, right? We'll be using square brackets for indexing notation. So this will allow to grab whatever the string associate with this index, right? So you can grab single character or multiple character with the use of this square brackets, right? So let me show you an example. So can you see here the character is there. So this is actually hello. The character is HELLO, hello. So we can index this one as 0. This is 0th index. This is the first index letter of the character. This is the second index character. This is the third index character, and this is the fourth index character. So this is the typical indexing or classical indexing, and you can reverse index this one as well, right? So in the reverse indexing, we start at -1, right? So from -1 we can count down, and -2, this is cell, -3, -4, and finally the finally the 0. So if you start with -1, that means the last letter of that specific string. That you have very important application with this one as well. I'll show you when we are doing exercises. So that is how we do the indexing for the strings, right? So you have the character and you have that character position associated with the number starts from 0. So if you want to grab this character or the H value, H character, you can use this index position 0 to grab that and use it whatever the application that you want to use, right? That is what you call indexing. And slicing it also, that means you can grab one character or like set of characters from LLO. So that is what you call slicing, right? So this will not harm the original data set, right? But still you can retrieve the data. So as an example, say you have first name and last name or some application, first and last name, right? So say that you need to grab only the first names. So you can grab it using slicing. So that is an example, right? So things like that can be done with string indexing and slicing, right? Okay. So for slicing, so for for indexing, you can just grab a letter, one letter, right? So slicing of string, there are more options, right? So when it comes to slicing, you have to indicate where it should start. Where should the slicing start? And where should the slicing stop? And what step? Step means, are we going one letter by? So let me write down. Sorry. So whether we are going letter by letter like this, one letter by one letter, or we can jump two letters by two letters like that. So this step is here one, right? This step is here two. So you can define what is the start and what is the end and what is the step, and then you can grab all these things to do whatever the application that you need, right? So that is indexing and slicing when it comes to uh, strings. Okay, right. So so let's do some examples in Jupyter Notebook, and we'll conclude today's session. So let me open this. Okay. So this part we did. Yeah, and strings. Okay. So this is how you create a string. Just a simple. Let me clear this one. So this is how you create a string. Just you can use single quotations to create a string, right? So this will create a string, and you can, of course, create an entire phrase using single quotations, right? So this will also create a string, right? And this is something, a string that we created using double quotations, right? The double quotations are there. So this is also acceptable, right? So this is also a string. The output is shown here. And finally, so see, now we have used only single quotation to create this specific phrase, right? So it's giving actually an error, because let me run this one. Because from here to here, it will accept it as a string, but afterwards the Python get confused whether to identify these single quotations as the string declaration, right? So when it comes to quotations like this, so as we discussed previously, it's better to use double quotations. See, so these double quotations can be used if you have a single quotation inside your string, right? So if you run this one now, see, it will accept it as a string value, and it will allow you to create that string value, right? So that is how you create and carefully create a string, right? So if you do you have any questions regarding this so far about creating strings? Okay, so I hope that you understood this the part until this one. So we'll be discussing about this string type in the next lecture, right? So please install this Anaconda environment. I will send an email as well with the link. Please install this Anaconda environment in your laptops, and from next week onwards, we can do these activities together. So you will be doing these things with me, so for you can understand these things. I mean, in a better way, right? So, do you have any questions until now about until up to now about the things that we did? So we just discussed about basic data types, and we did some exercises or demonstrations how to create different type of numbers, and how to assign variables and how to reassign variables. And we discussed about string types. We started to discuss about string type, and we can conclude that one from the next lecture. So are you okay with that one? Okay. Okay, thank you very much. So let's meet up in the next week, and we'll discuss about this further. Okay. So no questions, right? So I will stop it. Stop the lecture now. Okay. Okay, thank you.